You are a human being, and one day you will die. But when you die, you can take comfort in the knowledge that you're part of something larger than yourself. You're a member of the human race. And as long as the human race continues, in some ways you do too. All of us, every living thing, are individual members in a cycle of life and death that began 4 billion years ago when that first single living cell divided into two. 2 billion years after that, along came sex. And birth led to more sex, led to more birth. And as long as that cycle continues in a species, death can happen in the background. It must happen, really. It may sound a little cruel, but in the bigger picture, the death of one thing is kind of meaningless so long as the species continues. Humans tend to divide life along the borders between species, and for good reason. It's not an arbitrary dividing line. A species is what makes the difference between eating a meal and engaging in cannibalism. Across the animal kingdom, individuals routinely do things that risk their own life to save members of their species. You almost never see that kind of behavior between different species. True, there are plenty of examples of species where eating one's own kind is an everyday act, and there are examples of adorable dogs adopting motherless lambs. But the chances are better than not that an animal will show preferential treatment toward a member of its species over others. Most importantly, though, any member of a species can combine their genes with another member and come up with new and fascinating ways to push the species further along the evolutionary path, where it's better able to grow and flourish. Homo sapiens, the species that you, me, and every human alive are members of, means in Latin, wise human, and it's a bit of self-flattery since it is the name that we human beings gave to ourselves. But here today, so far removed from our ancient origins, it's easy to forget that the name is meant to distinguish us from other types of humans. As recently as 50,000 years ago, we shared this planet with no less than 3 other human species. In the same way you might walk about the earth today and come upon a lion, one species of cat, and a tabby, an entirely different species of cat, in the very recent geological past you would have been able to meet with a Neanderthal in a French cave, and a Denisovan in Siberia. And had you wandered on down to Indonesia, you would have been able to meet a tiny variety of human called Homo floresiensis, who stood 4 feet tall. Today, though, there is only the one species of human, us Homo sapiens. We can't say for certain, but we strongly suspect that the ultimate reason why we are the only ones left is because of our intelligence. Perhaps the planet was presented with a series of tricky environmental challenges, and we were the only ones intelligent enough to successfully negotiate them. Maybe it was the universally devastating step in the Great Filter. Or maybe that's not right at all. We've only recently discovered that Denisovans and Floresiensis existed, but we've known about Neanderthals for some 200 years now. And over time, we've come to realize that they weren't the dimwits we initially took them for. We now know that they used tools like us, and they may have mastered fire as well. And Neanderthals might have been the earliest humans to bury their dead, which shows the capacity to think about abstractions like an afterlife. Whether or not we were the only human species with the capacity for abstract thought, the one thing we can say for certain is that we Homo sapiens are the only ones left on Earth to wonder at the immense responsibility we have to simply carry on as the one single remaining species of our kind. That responsibility to survive and thrive is big enough, just being the only human species left on Earth. But it grows to overwhelming proportions when you consider the idea that we could be the only intelligent life in the whole endless universe. The precariousness of our situation begins to sink in. The Fermi paradox appears to show that the entire future of intelligent life in the universe rests on the likelihood of us staying alive. The entire population of Homo floresiensis, the species of tiny humans, lived on a single island called Flores in modern-day Indonesia. They lived there for almost 150,000 years, and then suddenly they disappeared. One current theory for their extinction is that a volcano erupted and killed them all off, which would have been relatively easy since the entire species dwelled only on that one island. We humans alive today call our island Earth. And we have to wonder what our volcano will be. Right now, there are about 7.5 billion of us humans alive. 7.5 billion is an enormous number, to be sure, but it's a small fraction, tiny fraction, of all the Homo sapiens who have ever lived in the 50,000 years since we emerged as modern humans. Early on, and continuing for most of our species' history, we had an extremely short average life expectancy, somewhere around 10 to 12 years. That doesn't mean that the average person died at age 11. It means that if you take all the people who lived into old age and all the children who died in infancy or at birth, so many people died young that the average age of death was dragged down all the way into the tweens. Plenty of people lived into what we would consider old age. It's just that many, many more didn't survive childhood. And this is how it was for most of human history. That extremely high childhood mortality rate was eventually overcome through the use of our clever sapiens brains. We figured out things like germ theory and anatomy and nutrition, and all of them converged to create a world that a child could be born into where they had a very good chance of surviving into adulthood. We humans used our brains to help our species be better able to survive. And as a result, our population began to boom. Around 2,000 years ago, there were probably 300 million people alive on Earth. About 350 years ago, the human population had grown to 500 million. 30 years from now, we will hit the 10 billion mark. So in just 350 years, we will have grown by 9,500,000,000 people. All told, you can count yourself as one of the 108 billion modern humans who have ever lived. An astronomical number, to be sure, but the number of humans who have ever lived, as immense as it is a drop in the bucket of the number of humans who haven't lived yet. This is philosopher Toby Ord.
Our species, Homo sapiens, is about 200,000 years old. So that's about 2,000 centuries that we've been around. If we could survive that long again, we'd see 2,000 centuries of civilization. That's about 20 times longer than civilization's been around so far, with just wondrous things being created throughout that whole time that we can barely imagine. And that's even with relatively little in the way of fancy science fiction technological progress that we might imagine.
Remember back when we talked about the possibility that we don't see alien life in the universe because they opted to stay home instead? Let's say that we humans have that same type of homebodiness in our far future, sticking around on Earth rather than spreading out into the rest of the galaxy. So Earth remains the only planet where you can find a human population. And let's say that over the course of 1 billion years, our population gradually lowers and stabilizes at 1 billion people alive on the planet at any given time. And if our lifespans stick around where it is today, then by 1 billion years from now, an additional 10 to the 16th power humans will have been born. That's 10 with 15 zeros after it. 10 quadrillion. 1,000,000 trillion future human lives. 108 billion doesn't seem quite so big now. That 10 quadrillion number is a low-end estimate. If we do nothing but continue to plod along as a species for the next billion years, we could expect to reach it. But we might also increase the number of future human lives dramatically if we humans innovate as a species. One of the ways that most futurists expect we will innovate is by leaving our bodies behind and entering into a digital world, becoming what's called a post-biological species. Imagine that we learn how to free the human mind from its bonds to the neurons and dendrites and axons that make up the functioning human brain. No real reason that the human mind should require cells to think and to experience. What if the human brain is just one of many ways to produce what we call consciousness? What if there are other ways that could produce the same thoughts, the same experiences, but with hardware instead of squishy, soft, extremely fragile material we call the brain? To understand how we could create consciousness inside a machine rather than a human brain, you should know a little bit about the hard problem first. Back in 1996, the philosopher of the mind David Chalmers published a paper where he divided our attempts to understand consciousness into the hard problem and the easy problem. The easy problem of consciousness is how it arises. How, for example, light can enter the eye and be carried along as an electrical impulse to the brain, where it's analyzed and sorted into the image of a houseplant. We generally understand how the various parts involved in this process work. We pretty much understand how the sights and sounds of the external world are perceived by us. There's no mystery to it. So although we haven't worked out every last detail of how consciousness arises from our brains, in Chalmers' view, we were well enough along that we basically had the easy problem licked already by the time he wrote his essay. The hard problem is how we subjectively experience those sights and sounds, how all of those experiences moment to moment combine and create what we think of as the experience of being human. Why is it that rather than simply observing the houseplant and deeming it neither a threat nor food and simply disregard it, instead you might be reminded of your dear sweet mother who loved houseplants? And maybe you'll also think about how perhaps a houseplant might brighten up your own apartment and maybe put you in a better mood because you've been a little bit down lately. In other words, why should we experience the inner life that we think of as ourselves? More to the point, where does this conscious experience come from? We can point to the language processing parts of the brain to show how we humans understand what the other person is saying when someone tells us they love us. But we can't point to the part of the brain that creates the incredibly rich experience those words can arouse in us. That is the hard problem of consciousness. To some people, we will never figure out the answer to the hard problem. Human conscious experience is too ethereal to ever understand. To those on the other side, we've already solved the hard problem. It's the same answer as the easy problem. All of those neurons and dendrites and axons that are responsible for communicating and sorting and storing the sensory input in our brains are also the same parts that are responsible for creating our conscious experience. We just haven't figured out how they do it quite yet. If that's true, and the hard problem really isn't a hard problem at all, there's a big implication in there. If consciousness is just an emergent property of neural complexity, like how tens of thousands of individual bees form a hive mind that is larger than the sum of its parts, then we should be able to simulate consciousness by simulating neural complexity. Maybe not today, maybe not anytime soon, but the point is it would be theoretically possible. And given enough time and technological development, it's a pretty safe bet that we will figure out how to do it. If there is an organizing principle of life that takes hold once molecules begin to take an organic form, then perhaps the biological form is just one phase of evolution. Perhaps post-biology is just another stage. If or when we become capable of uploading human minds onto computers, the number of future human lives will increase exponentially. And those lives can be expected to be exponentially better than the average life of those of us alive today. If we are the only intelligent life in the universe, then that means that should we become capable of spreading out in our galaxy, and then eventually throughout the rest of the universe, it will all be there for our taking.
The farther out we look in more detail, and the more clearly we see there's nothing at all alive anywhere in the universe, then it says we are really quite special. Not only that we are special for having, created cars and televisions, we are just special for being on a planet that has life at all. And the universe will remain dead until the life on our planet spreads.
That was great filter theorist Robin Hanson. Once we spread beyond Earth, we will reach one of the largest milestones in the history of our species. In the history of life, really. We will no longer be earthbound. We will have become a spacefaring species, with an entire universe to explore and use for whatever we want. All of the resources, material, and energy in the universe that we can reach before it inflates beyond our grasp is there for our use and ours alone. This is what an Oxford University philosopher named Nick Bostrom calls humanity's cosmic endowment.
And the key thing about it is that it looks like it's astronomically large.
Every last scrap of accomplishment that we humans have managed to achieve in our relatively short time here on Earth has been created with extremely limited resources compared to what will be available to us when we begin to spread out around the universe.
If things are the way they look, then what we have been able to lay our hands on so far is a period of time, maybe 1,000, 10,000 years of human history and some 100,000 years of prehistory. That's kind of our species tenure so far. And we've been confined to the surface of planet Earth, which is this little crumb floating around in a huge silo of material and energy and resources. So it's one planet in one solar system out of 100 billion solar systems in this galaxy, which is itself one of maybe 100 billion galaxies that could be reached from our starting point and then used for billions of years. So if you add all of those orders of magnitude together, you find that by some very large number, it dominates what exists today or has existed through human history.
What will we do with all that stuff?
I don't know, but it at least seems to me that protecting our chance to do that is critically important.
If, as a great many philosophers throughout history have believed, the point to life is finding happiness, then we could use it to pursue happiness on a massive scale.
If you, for example, think that happy people or minds experiencing pleasure or beauty or doing interesting things have value, then there could just be a lot more of those in the future.
A lot more, like a quadrillion more. And that number could grow exponentially higher if or when we reach that point of post-biology. Like any post-biological civilization, we would place a pretty high value on converting all of that into computing power. The science fiction author Ray Bradbury once estimated that the energy captured from a star could power 10 to the 42nd computer operations per second. So Nick Bostrom took that figure and he applied it to a post-biological society with access to all of the stars that we can reach in the universe until they inflate forever out of our grasp. If the human brain makes in the neighborhood of 10 to the 17th operations per second to produce our conscious experience, then it's a pretty fair bet that's about how many computations per second we would require to experience consciousness in digital form as well. So considering those numbers, and more, Bostrom included some other complex astronomical figures as well, he arrived at the low-end estimate, the low end, of 10 to the 52nd power future human lives waiting to be lived. Expressed in American English, that is 10 sextillion lives. That's a real word. A number so astoundingly large, it might be trite to even mention that it is. And you could make the case that in many ways, essentially every way, those humans in the far future will live better lives than those of us alive today.
Because natural selection didn't design us to be happy. Discontent, other things being equal, is adaptive and fitness enhancing. And as a transhumanist, I very much hope that we're going to be able to design a civilization based on, to use a slogan, a triple S civilization based on super intelligence, super happiness, and super longevity.
This is transhumanist philosopher David Pearce, who is among the number of people who believe that humans have a long and potentially bright future ahead of us. Humans might use all of that power to simulate amazing new experiences for ourselves that we haven't considered yet, and that would be utterly impossible in our physical reality. We would be able to expand and edit our consciousness, our faculties, our ability to empathize with others, our capability to experience emotion. What we alive today might consider the highest states of happiness may be the baseline happiness for all new humans born into a digital world. And so the humans of the future would be blissed out all of the time.
Here's an example. One sees today the effects of a drug like MDMA, ecstasy, or a hug drug, in which essentially people become loving, bonobo-like, warm, empathetic, jealousy, resentment evaporate. For evolutionary reasons, people aren't like that all the time. But with the use of some genetic tweaking, it would be possible to create people, transhumans, posthumans, who love each other in the way that people fleetingly do today on MDMA. Just how likely this scenario is, I don't know, but in the long run, it's certainly feasible.
Because we live in a world where we must compete with one another and other life on our planet for resources, what the future might be like in a world where scarcity doesn't exist is largely inconceivable to us. Suffice it to say that life can be better than it is today, should we make it there. We can't forget the possibility that between us and all of those countless future lives sits the Great Filter. Back in the summer of 1976, a space probe launched by NASA called Viking 1 flew over Mars. It photographed the planet's surface for the first time in human history. And prior to landing on July 20th, Viking 1 flew over the Cydonia region, a bumpy transition zone between the planet's cratered north and the flat plains of the south. And within those images that it sent back to its controllers at the Jet Propulsion Lab on Earth was a particularly striking one. It showed what looked to be a massive stone face wearing a ceremonial headdress. It looked a lot like an ancient monument on the surface of Mars is what it looked like. It became one of the more famous images in the world, the face on Mars, and it stirred the imagination of Earthbound humans about a potential Martian past where a great civilization once lived and thrived. But when the Mars Global Surveyor flew over the site in 1998 with a far better camera than the Viking 1 had on board, it was clear the face on Mars was just another mesa, shaped not by ancient Martian hands, but by Martian wind and erosion. But what if that 1998 image had confirmed the wildest speculations, and we had mounted an expedition to Mars to investigate?
The governments of Canada, Japan, and the United States, the three countries leading the International Mars Expedition, received a bundle of dispatches from the astronauts investigating the Mars anomaly today. Newly discovered structures that appear to be ceremonial halls and temples, built from a yet unidentified metal, further confirm the one-time presence of an advanced civilization on the Red Planet. President Clinton was in New York today to meet with other...
News like this would not bode well for those of us living here on Earth. As Nick Bostrom points out in an article that ran in Technology Review in 2008, if we were to find evidence of other intelligent life elsewhere in the universe, it would strongly suggest that the Great Filter lies waiting ahead of us. News like that would tell us that it's not so tough after all to get past all the steps that led to us. Other life managed it too. We would learn that we are not special and unique, and so the likelihood would be that the Great Filter is not somewhere in our past, which means that it must be somewhere in our future.
Everything we've ever imagined that could go wrong is a candidate for a future filter. So, take out all of your favorite disaster stories and fears and add them all up, and it might be in there. It might be something we haven't imagined.
If it is the case that the Great Filter is in our future, then the reason that there is no intelligent life in the universe other than us is because none of those who came before us were able to make it through the step that lies ahead. The more you learn about the kind of risks we humans are beginning to take on, the kind that make up the worst of those disaster scenarios Robin Hanson mentioned, the more convincing the idea that we are now entering the Great Filter becomes. It's probably about here that you should meet Nick Bostrom. He chimed in earlier, but what I mean to say is that you should know more about him, as his work forms a lot of the basis of this series. In Oxford, England, there is a university, among the world's oldest, where people have been teaching since at least 1096, nearly 1,000 years. And housed in a 3-story tan brick administration building called Littlegate House is the Future of Humanity Institute. The FHI was founded by Nick Bostrom, who, as I said, is a philosopher, and it is a center where people from a wide array of disciplines come together to consider the ways that humanity could accidentally wipe itself out in the near future, and also how to prevent that, and also what we might do with ourselves if we're able to negotiate the very tricky near future and actually survive into the far future. A great many of the ideas in this series came from those collaborations that arose at FHI. What Nick Bostrom mostly thinks about are existential risks. Existential risks are threats to life that have consequences so sweeping, so utterly catastrophic, that should one of them befall us, it would spell the end of humankind. No more humans, and if it turns out that we are the only intelligent life in the universe, no more intelligent life anywhere at all. What makes existential threats so dangerous, in addition to the catastrophe they bring, is that they are unlike any other type of risk we're used to encountering. With virtually every other type of threat posed to humans, we can reasonably expect that enough of us will be left alive to continue our species should one befall us. Take a disastrous change in climate, for example. Imagine that a couple of decades from now, we humans are caught totally off guard by a sudden shift in the global climate, far more pronounced and abrupt than the warning signs we're currently experiencing. A rapid rise in sea levels drowns coastal towns around the world, sending huge populations of people inland, which puts an enormous strain on the cities that absorb them. At the same time, massive droughts and floods break out in virtually every food-producing region of the world. The ecological collapse leads to social collapse. Food supplies dwindle, water supplies become salty, an untold number of people begin to die, more than ever have in human history. Even more are killed in wars that break out over the precious resources that remain. In just a handful of decades, the entire human race is reduced from 10 billion to just 100 million people, living in scattered settlements across the globe. As categorically awful as such an experience would be, it would not spell the end of humans. Even with just 1% of the population left alive, we could reasonably expect that 100 million people living across the world would be enough to carry the human race along, and eventually to rebuild. To be sure, we would be set back substantially. All of the progress that we had made as a global civilization would be pushed back thousands of years, almost to square one. Almost. There's a substantial difference between the perhaps fateful series of events that led to the discovery of something like smelting iron and carbon into steel, and having people who remember learning that if you add carbon to iron, you can make steel. Or that there's such a thing as coffee, or that you can make wine from grapes. And if you spin a magnet inside a spool of copper wire, you can generate an electrical current. And if you pass steam through a turbine, you can use it to spin that magnet, so you don't have to stand there and do it yourself. The memories of all the ideas and discoveries that accumulated to make up the general knowledge base of the average human walking around on Earth would remain, and would provide an enormous advantage for those left to rebuild compared to those who built in the first place. Consider that it was perhaps only 10,000 years ago that we began organizing ourselves into complex societies for the first time. Those early settlements and cities, like Catalhuyuk in Turkey and Mesopotamia in Iraq, that served as the earliest attempts at communal living, agriculture, government, law, trade, and everything else that forms the basis of modern civilization, are only about 10,000 years old. So even being set back to the beginning, even with 99% of humanity suddenly dead, we could reasonably expect that people could get back to roughly the point where we're at today within about 10 millennia, which sounds like a long time, but remember, we're talking about time on geological and cosmological scales. 10,000 years is a blink. Throughout our history, we humans have survived plagues, floods, droughts, supervolcano eruptions, just about anything Earth could throw at us. And we've always had enough of us left after a catastrophe to continue on, for forward momentum to slow sometimes, but never to halt entirely. And those eons of experience of disaster and recovery form the basis of how we learn from the world, a process you may know as trial and error. Imagine that you're a chemist working on a new explosive. As is customary, you keep detailed notes as you go along. And then one day, you're in the lab when, boom, you blow yourself up. You are in a great many pieces, but your notes are intact. And so other chemists can come along, consult your notes, find where you went wrong, and then try again with a slightly different formula. Now, this process can continue indefinitely, as long as it takes until we master this new explosive. So long as there are chemists who take good notes, who are willing to risk blowing themselves up and are never all in the same lab at once. This process of trial and error is so glaringly obvious that it seems not even worth spelling out. But it is, because the process of trial and error is how we've gained virtually all of human knowledge about the world to this point. And understandably so, because it works. But trial and error doesn't work with existential risks.
When it comes to other risks, humanity is very good actually at learning from trial and error. And we have some failures and we rebuild.
This is Toby Ord. You've met him previously. He's one of Nick Bostrom's colleagues at the FHI, and he's literally writing the book on existential risks.
But when it comes to existential risks, failing even once means we've lost permanently our potential for the future. So we can't have any failures, which means that we can't use our most successful way of learning, trial and error.
What separates existential risks from all other types of risks is the outcome. The potential consequences of existential risks are so catastrophic that if something goes wrong with them once, that's it for humanity. With these types of risks, there isn't any 1% of humanity left to carry on. There are none of us. There's no trial and error with existential risks. It's more like trial and sudden nothingness. We can't go back to the drawing board to figure out what went wrong and try again. The drawing board will have been vaporized, or there won't be any people left to write on it.
And that's very different from many kinds of risk because, first, there's no redo. If we accidentally trigger some sort of existential risk or are exposed to an existentially destructive event, that's sort of it for humanity. But beyond that, lots of the mechanisms that we use to manage risks stop working.
That was Sebastian Farquhar. He too is a philosopher at Oxford, and he too is with the FHI. Another name for existential risks is low probability, high consequence risks. Fortunately, the possibility of a bad outcome befalling us from any of these risks is remote. Normally, we wouldn't give them much thought or any thought at all. But these aren't normal risks. The potential bad outcome is so great that even though they have an extremely tiny chance of happening, they are still worth thinking about and trying to mitigate. And that is just what Nick Bostrom in The Future of Humanity does. Back in 2012, in a paper on existential risks, Nick Bostrom included a handy graph for categorizing different types of risk. Along the x-axis, the horizontal one, I always have trouble remembering that, is the severity of a risk, how catastrophic its outcome could be. Bostrom has ordered the severity from imperceptible, like losing a single hair off of your head, to endurable, like having your car stolen, to crushing, like dying in a car crash. All of those terrible events are ones that happen to a single person, which is the first category along the y-axis, the upward one, which is the scope, or how many people that the event affects. This category starts with personal and moves up to local, global, transgenerational, affecting more than one generation of people, and pan-generational, affecting every generation from that point on. Graphs are, of course, a lot easier to take in when you see them rather than to hear about them, so let's just say that the upshot of all this is that you can take any event and plot it on the graph to find if it qualifies as an existential risk. So let's do that. Take the death of a local baseball mascot. We'll go with the Richmond Flying Squirrels for no reason whatsoever. Let's say that the team's mascot was doing his thing up at the top of the bleachers when he fell over the side, all the way down to the concrete below, dying instantly beside the ticket booth. This would be a very sad day, not just for the person who wore the flying squirrel costume, but also for their family, and maybe even a sizable portion of the Richmond, Virginia area. So we can say that this would be a local event, since it affects more than just one person or one family. But it definitely doesn't affect humanity as a whole. And since the Flying Squirrels family and residents of Richmond will be able to carry on, then we can say that it will be an endurable event. So the tragic accidental death of the Richmond Flying Squirrels mascot would be a local endurable event. Let's up the stakes a little, shall we? How about a global thermonuclear war? This would obviously be a global event, and it would affect in some ways everyone alive at the time, whether through fiery death or from radioactive fallout, starvation during the nuclear winter, being forced out of one's home to find a safer place to live, you can make a pretty good bet that a global nuclear war will affect everybody on the planet. And depending on how bad the outcome was, the after effects it has on society could continue on for some time, affecting multiple generations of people. So perhaps it would be transgenerational in its scope. But it would be pretty unlikely that it killed everyone alive at the time and wiped humanity out of existence. There would almost certainly be enough survivors to carry on, and as we saw with that climate change disaster scenario earlier, they should eventually return back to where we were prior to the nuclear war, and hopefully smart enough to avoid doing it all over again once we got there. So for humanity as a whole, a global nuclear war would be a transgenerational and durable event. But if you follow the scale, this handy graph, up and to the right, you will find the point where existential risks live. Pan-generational, crushing events. We don't make it through those. But those are exactly what's coming down the pike. Right now, we are creating new technology that poses risks to humankind in a form we've never encountered before. A kind that dwarf global nuclear war and climate change. And we are wholly unprepared for them. My hope is that this series, in some small way, will make us aware that we need to prepare, that there is a safe path through the coming treacherousness. But we have to plan for it now. If we can make it through the process of mastering the new technology that will define our world, artificial intelligence, advances in biotechnology and particle physics, nanotechnology, we may secure a very bright and very long history for humanity, reaching long into the far future and spreading across the universe. Technology that poses an existential risk to us now is the very same that can prevent existential risks from befalling us once we've mastered them, a point called technological maturity. We're entering the most precarious period now, the point between where those unprecedentedly dangerous technologies come into existence and where we have them fully under control. Any time between those 2 points, one single slip-up, one single lab accident caused by one single person, one single failure to plan, one single oversight, could bring about the sudden, rapid demise of humankind forever. Turning our back on our destiny won't help us. The die is already cast. Some self-imposed return to the Dark Ages won't reverse our momentum into the Great Filter. That we will go through it has become inevitable. Even during the actual Dark Ages, that period of modern human history where we supposedly stopped progressing intellectually, was filled with pockets of people and entire cultures around the world still discovering, still innovating. And so it would be as well if we all foolishly banded together to try to halt the progress of science for fear of the risks it poses. We are not equipped to prevent science, and we would not want to even if we could. It is science that will expose us to these risks, but it is also science that will free us from them forever on the other side. And it's not just us who we have to carry on for. It's the entire future of the human race. We're carrying all of those 10 to the who knows what power future humans on our shoulders. As we walk this tightrope over ruination, the way to ensure our survival is not to concentrate on what's ahead, but instead to look down, to plumb the void below. The only chance we have of navigating existential risks is to understand them. On the next episode of The End of the World with Josh Clark.
The sun will basically fill up our entire sky. You look out the window, it'll just be a big, seething mess of star.
We've lived with natural existential risks since the dawn of humanity. When bad things happen to Earth, they happen to us as well. And that will be so as long as we remain an earthbound species.